Hello, welcome. Today let's try to solve another Leetcode problem, 269, Alien Dictionary. So let me first explain the problem, and then I will go back to the code editor to finish the coding. Yeah, so let's try to use an example. So for this Alien Dictionary, for example, we have a letter of A and B inside of the array, and we also have another word B and A. So this is valid, yeah, because we're gonna only tag this letter A with this letter B, so it means A is before B. Yeah, it works. So this is A is before B, and while B is the first letter after B, it can be any kind of letters. It means we're gonna always compare the two neighboring word, and if A is preference of B, yeah, so it means if A is before B, so we have a structure of A connected to B. Yeah, so if there's another character, for example, there's another letter here, it is C, so it means B is before C, so it means B will be connected to C. So we're gonna build this kind of a structure. So if we have three letters A, B, C, and inside the word, how many unique letters? There's also three. If they are equal, so we're gonna get the true. Otherwise, we're gonna return a false. Yeah, but there are also some other tricks. So for example, if the first word is ABC and the second word is just AB. Yeah, so for this example, the first letter is the same, so we're gonna check the second, and then we're gonna go to the third. Yeah, but here there's nothing. Yeah, but for this case, if we didn't find a letter inside the first, which is not equal to a letter inside the second, yeah, if we didn't find such case, we're going to compare the last of the first letter and the last of the second letter. So the last of the first letter is 3, and the last of the second letter is 2. 3 is more than 2. So it means this is not possible. This is going to be a false. Yeah, because AB would always be before this ABC, because C is just a suffix of AB. Yeah, so this is according to the definition of the dictionary. So yeah, for any kind of a dictionary, it will be like that. So this AB will always before ABC. Yeah, but we cannot check the sequence, only use the word, for example, AB. Yeah, we cannot get the definition for this word. For example, this is AB. We are not sure A should be before B. We are not sure about it because it's just inside a word. It can be BA. B can be also pointed to A. Yeah, we have to compare the pairwise word. We cannot check a unique word because there's no solutions for the unique word. We have to compare the pairwise word. Yeah, now let's just go to the code editor to finish the coding. So for this one, I'm gonna use the topological sort, and specifically, I'm gonna use the BFS topological sort. I'm gonna prepare a unique letters because I wanted to check how many unique letters inside all the words, and I'm gonna prepare the in-degree dictionary. Yeah, because for this one, I think you can also prepare 26 letters, or you can just use a dictionary because I don't know how many letters. For example, this may be just 5. I don't need to initiate 26 spaces of array. Yeah, I can use a dictionary. So for the unique letters, I'm gonna use a set. So inside of the set, I'm gonna check for C in word and for word in words. So here should be C. Yeah, it will be like that. So I'm gonna take all the unique letters. So say for word in words and for say in word. So in this way, I'm gonna check all the unique letters. Now I'm gonna prepare a graph and integrate. So the graph would be a default dict, and it is a list. And for the integrate, it's gonna also be a default dict, but inside it's gonna be integers. Now I need to initiate the zero integers. So for each of the character, I'm gonna prepare the value of the integrate to be 0. So for say in unique letters, so the integrate say would be initiated to 0 because this is the preparation for the BFS and for the topological sort. Now I will prepare the graph and integrate. So let me prepare just AB, just the two word. In Python, we can use pairwise. Pairwise the words, so it will be prepare all the words in pairwise. For example, those two as a pairwise, and this two will be a pairwise. So those two as a pairwise, and those two will be a pairwise because I'm gonna check the letters in the pairwise words. Yeah. Now I'm going to check the letters. I'm gonna use X and Y in zip A and B. So this zip is just for checking the pairwise. So for example, the first length is 3, the second length is 4. So inside of the zip, it will always check the first 3 letters. It will not check the fourth because there's no fourth letter in this word. Yeah. Now I'm going to check it. So if X not equal to Y, so I'm gonna prepare the graph. So it means they are not equal. So it means X should be pointed to Y. Yeah, because if they are not equal, it means X should be before Y. I'm gonna check X first and then go to Y. So for the integrate, it should be Y, should be plus equal to 1. So here I'm gonna use else. If I find one of the situations, I'm gonna break it. Otherwise, I'm gonna use else. So inside of else, I'm gonna check if the length of A more than length of B. So I can return an empty array. So this just means what I said before, ABC and AB. If this is more than 3 is more than 2, so I'm sure I'm gonna return an empty string. I didn't find a solution. Yeah. So this is according to the question. If I didn't find it, I'm gonna return an empty string. Otherwise, I'm gonna return a sequence. So this sequence can be any kind of sequence. I just need to return one of them. Yeah. And the structure here is not always used in Python. I'm not sure if it is used in other languages, but in Python, this is even rarely used. But this can save a lot of code. It is called for else structure. Inside there is a break. Yeah. So this means if here, if x not equal to y, definitely we're gonna execute the break. So this break means if we break it, we will not execute the else areas. If you don't use an else, so this ones will still execute if this if is just here. Yeah, if this if structure is just here and there's no else, we're gonna still execute. So this is why we're gonna use a for else structure inside of the break. If there's no break, we're gonna execute this else immediately. We're gonna check it. Yeah, so basically this is the main code. After that, it's gonna be it's gonna be a template code, just using the BFS. Now let me say I need also to prepare result and queue. So for the result and the queue would be an empty string, and the queue would be just the queue. Inside it's gonna be ID for it's gonna be I for ID in enumerate the integrity. If D equal to 0. So this is just preparation for the queue. Yeah, after preparation, we're gonna do some operations for this queue, and we're gonna do some operations for its graph. This is just preparation. After everything is prepared, I'm gonna prepare the BFS. So for the BFS, so while queue node is just a ladder, it should be q.pop left. You can also use pop right, it doesn't matter. So here I'm gonna use a pop left. Yeah, you can directly use a pop, it's okay. So the result should plus equal to the, yeah, let me put the result and queue here. Yeah, because it should be calculated first, and then I'm gonna prepare this queue and the result. Yeah. Yeah, so let me put it here. Now I need to use the result plus this node. So this is just a ladder. And then I'm gonna check the neighbor. So for neighbor in G node. So for the integrity of this neighbor should be minus equal to 1 if integrity with this neighbor equal to 0. I'm sure I'm gonna put it inside the queue. Yeah. So after that, I just need to check the result. I can return the result if length of result equal to the length of the unique ladders. Yeah, it means, for example, there are 5 unique ladders, and I got a sequence of 5 ladders like that. I can return this result, this 5 ladders. Otherwise, let me check. Yeah, do I need to? Yeah, otherwise, if I didn't find, I think I'm gonna return an empty string. This is actually the entire code. Let me check. Something wrong. Yeah, let me try to print out this result to check what's inside, and also the integrity. Yeah, let me also prepare this queue. Oh, inside the queue there it is empty. This is a string. I think this is why I return an empty string. Yeah, because inside this queue, it must have something. Let me check. For ID, enumerate integrate. Yeah, let me just prepare the integrate as well from here. Yeah, let's see what's inside. Yeah, W should appear inside this the queue, but it didn't. So this is the strings. Yeah, as you can see inside the queue, it should have inside the integrate, it should have 0. Yeah, it's not enumerate. I did something wrong. It is integrate.items because it is a dictionary. It is not array. Yeah, now let me run it to check. Yeah, as you can see, it works. Now let me just remove this lines of code and try to submit it again to check if it works. Yeah, as you can see, it works and it's pretty fast. Now let's analyze the time complexity. So for the time complexity, we're gonna analyze two parts. So one part is for the preparation, another part is for the BFS. But the whole part is called topological sort. Yeah. So for here, for this one, actually, so the length of the word, we just call it n, and each word, the length of each word, we call it is m. So for this one, it is m times n. It is less than 10,000. And also for here, it's just the unique letters because there are 26 unique letters, so it doesn't matter. And for this one, we're gonna check the pairwise the word. So how many pairwise the word? It is 100, right? It is also n. And inside each of the word, it's gonna also be m. So it is the m times n from here. Yeah. So up to here, the time complexity is m times n. It is 10,000. Now let's check about here. So here is just topological sort structure. If we have the topological sort, it is just a graph. So we're gonna traverse each of the vertices, and we're gonna check each of the each of the edges connected with it. So for here, I think the time complexity is e plus v. E is the number of edges, and v is the number of vertices. Yeah, so I think it should also be like 10,000 m times n. Yeah, because the edges always be more than the number of vertices. So for the edges maximum, it's gonna be v squared. So the time complexity would be the maximum of e plus v with this m times n. Yeah, or yeah, this is it should be bounded in 10,000. Thank you for watching. See you next.